right, 2005 scoring guidelines, question 1. So they gave you this figure, right? And they gave you F and G. And the big thing on this one, immediately, you see that they switch top and bottom. There's 2 regions. They label R and S. And they say find the area of R and find the area of S. And they go through a whole lot of wordage to show that the shading is what's there. That they pin it to the x-axis, to y-axis, and all of that. All right? So when I want to do region of R, right now notation is a big thing. And going to Calc 2, notation is huge, especially in college courses. I'm a pretty good stickler at it. I would not waste a lot of time, and I would start with this. 0 to A, and I can see that it's G of X minus F of X dx. All right? Now, I got to figure out A, right? But I would do that and write that immediately because I know I'm going to get some credit for that, okay? Because, if I fell over and that was all that was left, I'd probably get the credit. By my TI-84, I have to enter these 2 functions into my calculator and find the point of intersection. You can do it either on the graph mode or use in the intersection key, or you can do it with your solver. But this is something you're not going to do by hand. I don't think there's anybody. You'd have to guess and check and do it by hand. It would be horrible to find that answer. I called it A. I get A equals 0.1782. And then over here, oh, looky, B was 1. Exactly. Okay? And I can find those 2 points of intersection rather quickly. So I'm going to set A to 1.1872, and then I'm not even going to write that number into my integral. And I'm going to just do the integral. Type it in my calculator, making sure that I put f of x in parentheses, so the negative sign distributes to the quarter and to sine x, right? Sine phi x. If you miss that, you'll get the wrong answer. That said, when you do that work, I got this. One of these 2 answers gets credit. All right, again, we go 4 decimal places here, and we get credit for 3. And this is another glory problem. 1 point, 2 point, 3 points. All right? Which makes you immediately think that the next one is most likely going to be the same. And since they're so similar, I'm not going to box it this time. I'm going to look at this and say, okay, region S just goes from A to B, f of x minus g of x, right, dx. And I would just, again, reverse the functions in my calculator, being oh so careful not to screw up. All right, and when I do that, this time it must have been pretty clear because I didn't write down what the last decimal was, but it was just that answer. And again, 3 points. The limits, the function, the number. Literally, I think we've worked for, it would take me a couple minutes to type them in if I didn't have it already written down for the sake of speed. But I would believe this one problem right now, we'd only be invested 3 minutes, right? Maybe 4. So this is a problem where we're going to have to get through to get to other things. I'm going to group it. You notice I didn't group my 2 limits, my A and B. I'm probably going to need those for C, is my guess. Pull those up into here. Find the bottom of the solid generator when S is revolved about the horizontal line y equals -1. All right. We have to realize that this is going to change at A. That this is going to be 2 integrals, all right, 2 volume integrals. Because when I do this, I'll just make this line right here. I have to do this, all right. Oh, I just want the S. I'm sorry, around S. So I have to do from A to B, all right. And again, I'm going to revolve it about the horizontal line. I definitely want to do this as a dx, right? Everything is for x. So volume equals, and I might even write it in this time. You guys agree it's A to B of AX dx. And actually, a to b is usually our general notation, but in this case, it ended up also being what I picked for limits. All right, based on this. Now, I see this as a washer. All right, so again, I beat this to death, don't I? But we see this as a washer, and we picture the inside radius and the outside radius. All right, and you have to see that the -1, it's going to be g of x minus a -1, right? It's going to get +1. That is the inside radius. So AB equals pi RO squared minus pi RI squared. Radius is dx. All right. I will pull out the pi. And you know what? If this was spacing down my page quite a bit at this point on my workbook, I might say, I might just do this one time in here so that they don't think I'm keeping the general form. You know what I mean? Because now it's kind of spaced away from A and B. RO is going to be 1 plus f of x, quantity squared. All right? 1 plus g of x, quantity squared for Ri, dx. And again, that's all I would write. I'm done writing. I'm going to type this in. I'm going to take my time. Again, this is one of those OR answers. It was either 558 or 559. And this was 3 points. It was irony, though. This was a point this time. This was 1 point. You had to have all of that stuff. If you forgot to write the pi and you put it in your calculator, you didn't get the point. All right? That said, the integrant was worth 2. All right? So again, not too bad a problem. Uses our understand how to find volumes of solids.
Excuse me for the following announcement. This time the girls' softball game for tonight has been canceled, and we're trying
Keep practicing.